Good morning, good afternoon, everyone. Welcome to this webinar. On behalf of Lineage Solutions, I would like to welcome you to Data Engineering with Python. It will be a 1-hour presentation. My name is Mikhail Vladimirov. I will be your presenter today. Our agenda is as follows. We will talk about what makes data engineering such an important discipline. We'll quickly review data-related roles. Data engineering is just part of that data-related roles that have been kind of cropping up recently. The core competencies and skills that are related to this role. And we will talk about Python, not very much in depth. We are not going to do a presentation in depth on Python. It will be more of a language, just ubiquitous language in the context of data engineering use cases. So that's the goal. And we will talk about Python libraries. Okay, so if you expect to hear from me how to run Python, Jupyter notebooks, and what would be the configuration to set it up on a cluster running Apache Spark, there will be nothing of the kind. It will be pretty much high-level overview of that new role and core competencies. That's what people are really asking for. By the way, if you have any questions, just send me a chat. There should be a chat window. You can do it privately, or you can send it to all panelists or all attendees. Okay, in this case, I would like to just give you some way to talk back to me. Currently, you are on mute. I can allow you to talk, but it will be a little bit of a difficult to maintain in orderly fashion. Okay, so let's continue. So there is this quote known by many that the future ain't what it used to be. And in fact, this quote is attributed to Yogi Berra, a well-known baseball player and coach in the States. But if you look at this quote, and which actually what he said, and you look at ain't as a sort of anomaly of that isn't verb, then you'll be able to trace that quote way down to around 1937, where other people like Laura Riding and Robert Graves were known to kind of use this phrase for the first time. Maybe it was used by someone else, but that's how far back you can go. There is a quote investigator website which does the thing. So what it means that outlier can actually, which is ain't instead of isn't, actually created that confusion as to what is the actual lineage of that phrase, right? And those are the topics that data engineers are facing. You can, I guess, rephrase the whole thing in terms of text analysis, data analytics, and natural language processing thing, name it machine learning and all that stuff. But in fact, it's just common sense and understanding of your problem domain. Problem domain is in language. We want to make sure that we pay our dues to those who use this phrase first. So that's pretty much in a nutshell what I guess the data engineering is all about. It's a little bit of a metaphor. It's not exactly. Some people might say, so what is the relationship? It's just a way maybe to appeal to other people who have this kind of a visual way of understanding things. So data engineering is it's a practice which is, has empathy with data. And what I mean by that is that data in itself, data is king, data is very important, it's our most important asset. But data is a living kind of a asset that needs to be ingested, processed, transformed. and stored securely or not securely on-premise, in the cloud. We are talking about security at rest, security in transit. So in many cases, data is also classified as big data. By the way, I want to make sure that you can see the slides, because I don't have the feedback on the slides. I know that you can hear me. Can you raise a hand if you can see my slides and you can hear me? Oh, thank you very much. Oh, very nice. So guys, thanks a lot. So let's continue. So hopefully those in attendance, they here for deliberate learning. Sometimes what happens, someone, when we deliver our classes, be it virtual, mostly it's about virtual classes, and you don't know the audience very well, and the audience is quite diverse, people coming from different walks of your organization. And it's very difficult to find that kind of a common denominator, something that would kind of match the needs of everyone. So my assumption is that you are looking at kind of getting, trying to get more information about data engineering, and you have specific interest in that, right? So probably more of the Python stuff, but what I found is sometimes people get stuck by just selecting a language and they think, I'm set for life, I don't need to do anything else. That's what everyone is using. It's not the case. You have to be prepared to be a polyglot programmer. Python is just one of the most probably important currently language used in machine learning and data engineering. There are other systems which we will mention shortly. So data-related roles, you can define three clearly distinct or not so distinct data-related roles. All those roles are interconnected, and the hierarchy of those layers start with the data engineer role. Those people are responsible for getting the data ready for data analysts and data scientists. It's a little bit of kind of maybe not hierarchically correct to put data scientists above data analysts, because business intelligence tools that data analysts use, in most cases, they are compatible with the tools and instruments that data scientists use. But data analysts are more business-minded people, where they know the problem domain. They have very tight relationship with people who take probably tactical and strategic decisions. They have kind of that they're embedded in that business fabric of organization. Data scientists or machine learning scientists are people who would probably be a little bit off the chart of that kind of a nice organizational hierarchy. They are more like hackers, more of data engineers who have experience or training in statistics and carrying out machine learning experiments using scientific methods. So this is a big slide. Probably you have seen it before. So data science is kind of a core competency, and many organizations are now trying to identify what would be a suitable place for this role. And in many cases, like business analysts, they take over that responsibility. They pretty much change their job responsibility, add that data science kind of a stanza, and all of a sudden you become a data scientist. But in fact, it's a number of things. So you have you need to, in order to establish this capability as important, helping your organization to make data-driven tactical and strategic decisions, you need to have lots of support from various fields. So data science is something that involves all those things in one way or another. Definitely math, statistics, the hacker mindset, kind of a crazy scientist type of approach, is very important. Domain expertise is important, but usually it's part of the business analyst role. And data engineering should be combined. You can probably rewrite this slide where data engineering plus advanced computing would be kind of a part that would be the realm of data engineering. So hopefully it makes sense what it is, but the whole idea is to set our data at the front and center of our focus, where we can convert data into actionable insights and bring value to our organization. So what are the, just a second. Do you have any suggestions on which role QA would fall into? That's an interesting question. Irene, data engineer would love to hear your opinion. QA, I would say QA would be someone supporting, if you, for example, really in data warehouse, and you are supporting, like you are QA, that person in the QA role, all the tasks, particularly when before they're being rolled out in production, all those scripts, they need to be tested on smaller data sets. So I would say it would be on the level with data engineers. So those people would be essentially approving all the scripts, all the transformation jobs that would be created by data engineers. But at the same time, definitely QA is not going to do anything with data analysis, but data scientists, they have models, and those models need to be verified as well. And the problem with scientists and engineers, they kind of don't have this destruction, kind of a seek and destroy kind of a thing, right? Like Metallica. It's not about that. It's about creating things, creating value, creating algorithms, and they're very picky about this. There should be someone who would step in and start kind of I don't know, bulldozing the whole thing. Just let's break, let's create an interruption here. What is the data feed is not available? Will we get a null point exception? So QA would definitely be present at the data engineer level and plus data scientist. Hopefully I was able to answer your question. Okay. Anyway, so moving on. So of course, skills and competencies, definitely programming skills. And it looks like Python is one of those languages. It must to know, but don't limit yourself. If you really want to become someone with high salary and must kind of go-to person, you should understand other things. Probably it could be Java, it could be R programming language. Data interoperability, file formats are very important. There would be a slide where we will have a discussion on how just understanding very simple things on the surface, they can make all the difference, right? And you need to understand, you are in the role of data engineer, right? So you're a data engineer, what is expected of you. So you need to work in the environment where you will be sort of kind of rubbing elbows with DBAs, sysadmins, data stewards, and everyone in this DevOps. Definitely, it's a very popular discipline now. And you need to understand the whole flow, sources, kind of data ingestion, ingress and egress points. What is happening? Who is the consumer of the data? Usually it happens right away. So if there is some misalignment and your data end up somewhere else, you'll probably have an angry call. So where's my data? And you will kind of gradually like uncover that urban kind of a tribal knowledge, how the lay of the land. So you're better off to probably when you are being hired or you are moved into that role, just to find out who is the consumer, who would be affected by that. It's very important because data engineer supports so many other activities that just consider the role of data engineer pivotal, very important. And efficient ETL, where you would need to understand such aspects of this processing as what are the time constraints. Can we process this job at what time, and the storage in terms of capacity, how much storage we would require. Lots of things, and the more you know in this department, the better. Because sometimes people just walk and say, okay, where's the script? Let's run it. Without understanding that pretty much you will be processing terabytes of data and you will get, I don't know, some sort of a system fault. Or you will just consume the network to the fullest, and there will be lots of scream kind of somewhere in that room. So you need to kind of become, the reason I'm saying that is that I haven't kind of introduced myself, but I've been in IT for more than 20 years. I'm a certified enterprise Java architect. I worked for banks, insurance companies, and startup companies. And when I joined, I guess, this current company, I understand that there's so much that people are just missing out. They're concentrating on certain aspects, and they want to stay kind of one language locked in, not knowing anything outside their very narrow vision, and that would impact your career. It would impact. Some people have problems with, I don't know, with lots of things. They're introverts. They don't like to communicate with people. Maybe their English is not up to the level, and they kind of say, whatever, just tell me what to do. But you are much better off if you become totally engaged in the process. It would help you. It will help you to grow your career, and it will help organizations that have hired you in hope that you will bring value. Okay, so just consider all those things. Those are kind of a soft skills, but those are competencies that you have to just master. So data modeling is a little bit of an advanced skill. You need to understand what it means exactly, how to partition data, what would be a duplicate burden if you have duplicate records, and both in terms of storage or in terms of updates, that kind of a ground truth knowledge. Not only SQL, but also NoSQL systems, but particularly now with Hadoop and similar systems, and any of the system running on Hadoop, be it Hive, HBase, Apache Spark, you need to understand what actually schema is, how to generalize data, and what would be the best approach. And good analytical skills. So there is this idea of data physics, how data is kind of moving around. It sounds a little bit maybe far-fetched, and some people say, so what are you talking about? Like data locality. If you are familiar with Hadoop, with MapReduce, essentially you invert that client-server processing interaction direction in reverse. So you need to understand this. Sometimes probably you would be better off to follow those steps, so that you, rather than getting the data over to your machine to process data, you would probably create a way that processing environment on that machine where you would process the data. It's kind of that data locality or intelligent data placement, job placement principle. CAP theorem, how you would consistency, availability, and partitioning, how you would ensure that your data is consistent. It's pretty much has a relationship with NoSQL systems which run big data. So just if you're not familiar, just search the web, and it's those concepts probably one way or another are familiar to you. And also you need to have a nice kind of a skill to be able to quantify, measure the data, to provide metrics, the quality of data. I don't know how much duplication you have. Do you have redundancies? A little bit of maybe data science terminology like features, labels helps to understand. And what's interesting is if you acquire those skills as a data engineer, the next logical step would be probably to try out some of the data science kind of tasks, and gradually you can grow and become more powerful and more empowered. Okay, so there is also a whole list of data engineering tools and other facilities that would help you to become maybe more diverse. There is no kind of a big hammer that would drive every nail in every wall. There is definitely a whole suite of tools that you can use, and the problem now is to match that particular use case with a particular tool. Of course, you can do it with a hammer, and but there are other ways to do the job with less distraction and more focus. So I mentioned like file formats and other aspects of file data-related modalities, so to speak. Here's a slide which captures a very nice visual picture of what you can achieve by just going from one format to another. And by the way, it's not about compression. It's not about gzip or snappy or something else. It's all about encoding data. So we've got half a terabyte original size text file stored somewhere, maybe in the cloud. And you'll be paying, I don't know, like $1 per month, per year probably, for 1 gigabyte. So it'll be kind of $1,000 for that gigabyte, and probably you'll be storing terabytes worth of data. RC file is no longer relevant, so discard it. Parquet and RC files. Those are the formats that will kind of influenced by protocol buffer from Google. So Impala, kind of we're pushing Impala. It's a Cloudera Hadoop vendor. They were pushing Parquet format. It's a columnar format. The Hortonworks, they took a similar approach, and they came up with ORC. So those formats are available, and they can drastically improve processing of the data, because data is stored in columnar kind of arrays. Those arrays facilitate queries. So pretty much you'll be querying against that contiguous data set. It will be very fast, and it also allows you to, plus with a little bit of a compression, you can have a significant reduction in the size of the file. And decompression is quite painless. So here's, you might say, okay, so what are we talking about? Hopefully some of you are familiar, but maybe some of you are not. And you might say, so what this Parquet thing is, right? We're talking about this blue Impala. Impala, it's a system, SQL-based system. Hive is, Impala, Hive, SQL-based systems in Hadoop ecosystem, where you would run those to extract data from raw data on distributed file system using the familiar SQL language. So that's what it is. We create a file stored in Parquet format using this CTAS. It's create table as idiom, which is supported by Hive, and I believe by Impala as well. So you run this thing on the cluster, and essentially you have a text file, and you would like to take that huge and quite unwieldy file, CSV format, and you just create a much smaller, more compact Parquet. And that's what it is. Create table, store as Parquet. So that's the standard that allows you to do that thing. Okay, as you see, if you understand the concept, when you understand this, you pretty much can bring so much to the table in your organization. So to maybe make it more kind of dramatic, here's another example. We're talking about data engineering tasks. So you might say, how would I kind of process the data, ETL, Python, all those kind of interesting stuff. But those are the fundamental things that people are just somehow missing. It would be probably a solution architect or someone kind of a high up data architect who would be telling you, guys, let's do this and that. But in fact, nothing really prevents you from taking the same approach where you say, okay, guys, what options do we have? Currently, Amazon Web Services, the cloud vendor, offers you this fantastic capability. It's, in my opinion, Athena. Athena allows you to run SQL queries. You can see those on the right, which is standard SQL with inner joins, with subqueries, grouping, heading, everything is supported. And by the way, there is a link that would allow you to access that presentation. Very good one, very much to the point. And on the cloud, you pay for what you have consumed. Okay. And what's interesting is, if you construct a query and you process 1 terabyte of data, they will charge you only $5 US, slightly more in Canadian funds, but that's it. 1 terabyte, $5. You don't have to provide anything. What you have to do, you just take your file and you upload it in the S3 storage. S3 is simple storage service, which is object store, which is quite durable. It has embedded replication to ensure data resiliency against failures. Probably will take you, I don't know, like maybe an hour or so to upload the data. Probably you'll be charged for the storage as well. But you might upload the data, process it, and then discard the data. So if you process the data, so what the point I'm trying to make here is that if you use uncompressed standard text file to run those SQL queries, and by the way, if you don't like Athena, you can create any JDBC client, whatever you want to use. There are so many out there. You just, Athena comes with a JDBC driver. So you run locally your very nice GUI you're comfortable with. You just drop the jar on the class path, and you would be able to just point to that S3 bucket where the data is, and that's it. The job is done. So 1 terabyte would take you 237 seconds, right? It's kind of it's nice, but probably those 4 minutes or so probably would be spent somehow else. You actually, in order to process the data, since there are so many touch points, you will have $5, 5.75, which is in the realm of possible. We can pay this even out of our coffee budget. But if you use this very nice formatting of your data, you can upload the data stored in Parquet format back into that storage location. It will reduce the data, and that was the actual experiment that they were doing at Amazon. 130 gigabytes, so it's just 1:7 compression, right? And processing would be 5 seconds. Before you can even kind of sip your coffee, it will be done. So a little bit frustrating, so you probably would need more time. But the point is, you'll be scanning significantly less data, and that data would be scanned by this SQL. And so we do selection of, it's just elastic load balancer, system log files, and sometimes for metrics, for statistics, how efficiently it works, they need to run this query. It's quite serious. It's just not kind of select everything from something. It's just more of a practical case. But the thing is, it would cost you 1 penny. 1 penny compared to $5, right? So when your manager or someone up would see that, they would probably just hug you. They would say, that's exactly what we need. So there are some statistics which is faster in terms of scans and how much it's cheaper. And that is the something that a data engineer should embrace. It's not about like running Python, right? And again, we're going to talk about Python shortly, but and you understand where I'm getting, right? It's much more diverse than just Python. So data lineage and provenance, it's very important in most enterprise use cases to have that visibility into the flow of your data from source, when you extract the data, through transformation, and then loading to a system or sending it off. That's part of the ETL. It might be a straightforward, just point-to-point, kind of a FTP file, and we are done, but it can be more convoluted. Lots of transformation steps, join points, intermediate data flow hopes. And for that, data lineage is a concept that allows you to create that queryable interface where you can say where my data was at this point in time. So who is responsible for processing? If you want to troubleshoot, lineage is a very important feature. And many systems do support it, so look for that, because data lineage, it's your biggest friend that you can get from those systems. And representation of those nodes, processing nodes, are straightforward: input, output, and transformation. So that triplet essentially combines everything. That's the metadata. There can be more information, but you can query, and you can find out, okay, pretty much we kind of messed up at a particular data lineage point, because before that, we can see the log files and we can identify that there is no problem. Okay, but also there is another term, data provenance, which is just another way, a more elaborate way to say that we are talking about data lineage. Okay, so those concepts, they should be near and dear to you. So we talked about three roles: data engineer, data analyst, and data scientist, machine learning scientist. And if you can see those legends, blue, orange, and green, that's with some level of approximation be the picture of data processing. As you see, earlier stages, we're ingesting data from the left to right, and at the utmost right, we've got data scientists kind of tweaking their models, performing testing of their trained models to produce the actual model. But data engineers are involved, and nothing really can happen successfully unless data engineer plays a good role. So that's the whole process is just logistically tight. There is no kind of a waste. And there is also a position for data analysts. They're kind of I don't want to kind of minimize their role, but it looks like the current trend is to expand for data analysts the roles of data scientists, but definitely they are not very good, and they are not willing to go into the realm of data engineers. So data engineering, if you kind of look at this again, you realize how important this role is. And it gives you a chance to actually make some inroads into the realm of data scientists on the right, as you kind of embrace, become more involved. So data processing workflow engines, a while back, if you've been around for some time, you remember there was in vogue those business process management systems, and there was a bunch of those. These are the open source, but also like IBM, Oracle, they had their own very expensive, very powerful systems. We also were familiar with Enterprise Service Bus, again, Microsoft, MSMQ, maybe WebSphere MQ, or MS Queries. That it was kind of a big name a while back. And eventually, I guess, big data systems, they just wanted to kind of re-implement those ideas in more practical aspects, and so that big data, or not so big data, because big data like 3Ds, it's not about size, it's not only about size, the size of the data, it's about velocity and variety of data. In different formats, data might come slowly and quickly in and out of your system. So Hadoop, Apache Hadoop ecosystem uses Uzi, Spotify has Luigi, Airbnb has Airflow. There are many more. Airbnb, it's a Python-based system. You can declaratively say what you want to do, but all the ideas are nothing new, and that's what I guess another message that I would like to get across. You just need to, I would say, try to find some logical bridges between what you already know and all those new things that you hear or that you see. So DAG diagram, so whenever you see this, it's just all about that activity diagram expressed in UML, where there is no coming back. Everything is just directed. Acyclic means there is no coming back. That's it. We're forging ahead. until we kind of fall off the edge of the earth, kind of thing. So Apache NumPy, it's one of the tools written in Java that is extremely versatile. Even though, again, it's not a Python-based systems, but this is something that you should really take a look, because it's kind of a distributed ESB, which allows you to use a lot of kind of I would say, those are the properties which make it indispensable in many cases, because everything has been already kind of thought of in advance for you. So you would have such quality of services as trying to find the balance between the latency and throughput, loss tolerance, guaranteed delivery, just duplicates are okay or not okay. Back pressure where you suppress the client, very kind of talkative, very verbose client, you just push it back. There is a way to do it on the TCP/IP level. It has nice web UI. There were big bucks behind this company. You can read the history. So it's a really enterprise-ready system. Many people are using it. So Python, some people might say finally, but hopefully you now understand the context. So Python is just one of the tools in data engineering use cases ecosystem. So it's object-oriented, as you know, it's functional programming, and functional programming means that there will be an example how to use map, reduce, filter. Object orientation, I wouldn't say that you should use Python for that. Object orientation is probably, it would be more of a scripting, where you would be imperatively kind of a loop, create list comprehensions, all that stuff, and use functional programming paradigms for processing data using Lambdas. Object orientation is great, but leave it maybe for other users, because in data engineering, the more complex your program is, the more difficult it is to debug, and you have more side effects. So you would probably be better off to focus on functional programming aspects. So Python in itself is quite sluggish system. It wasn't created for all those use cases that people are currently using. It's pretty much what happened with Java. It was kind of developed originally by James Gosling a while back for specific uses at Sun Microsystems, company that once was. And they just, I guess, didn't foresee in their wildest dreams what would happen with Java. Java 2EE, Java EE, and all that stuff. So NumPy and pandas are those kind of supporting technologies that make Python extremely efficient. NumPy is just a native bridge to step out into the memory managed codes using C, where you have kind of memory allocation done using pointers, and then you just pass on your list of objects, which would be very slow structure, but then you pretty much convert it into NumPy arrays, which would be extremely efficient. You would be operating at C level, at machine level speeds. So scikit-learn is the way to extend primary data engineering tasks into the area of machine learning. And in addition to that, scikit-learn does you much more. Visualization is supported. A very popular web UI ID is Jupyter. So Jupyter notebooks are have been very well accepted, and it's not only available for Python, it's available for other systems like R. And Python on Spark, the PySpark brand is very popular for processing massive amount of data. It's a parallel processing system which supports the traditional ETL tasks as well as machine learning, which would be performed on a cluster. And essentially, you can get maybe 2 orders, maybe 3 orders of magnitude better performance compared to single-threaded Python application running locally somewhere. So here's the Lambda. This is functional programming example, and let me just walk you through quickly. Most of you might understand it, but I guess it's worthwhile to recap a couple of things. So map, reduce, and filter, they are highlighted in red, if you can see it. It's just a way to wrap up the algorithm, the implementation, and keep it under the wraps. You are only interfacing by passing parameters and specifying the behavior that you would like to apply to the source. So in order, for example, apply this transformation, bring every element to the power of 2, taking this input array, you essentially create this map. Lambda is just an anonymous function, and Lambda is a name, just a moniker pointing to that class of Lambda function. It can be another function, named function, but Lambda is just a nice way to quickly write up code where you have just an expression which can be evaluated in one go, in one shot. Okay, so we've got very nice output. We wrap it up in list, and we've got our task expressed quite nicely. And the beauty of functional programming is that we don't care. We don't see, and we don't care how it was implemented. It might be implemented on a multi-threaded computing engine, or it can be done on a cluster of machines. It doesn't matter. And that's what, by the way, PySpark, Python on Spark, allows you to do. You can apply map and reduce transformations to resilient data sets, and it happens on the cluster. You can have potentially hundreds of partitions where your process will be processed in parallel. So reduction, you need to do imports with version 3. They change certain things, and we can find the sum of elements. Again, nothing is really obvious how to do it, but that's how it's just boilerplate code. Right, and you can do filter. So filtering, we just select those even numbers. Okay, and again, it's just a nice way to embrace functional programming. A little bit of practical kind of examples of how you would go about using Python, and you would usually be involved in repairing, normalizing data, fixing data, removing outliers, maybe removing duplicates. Data might be missing, data might be in consistent formats, spelling of, I don't know, provinces or states in the country, and outliers. What would make a particular value an outlier? Is it really critical, or is it something that we probably throw the baby with the bath water, right? We should be aware, and again, that data understanding of your problem domain might help you in a big way. A normalization of data helps with comparing things. Sometimes data might be different scales. It might be pennies versus millions of dollars, right? So what essentially we're talking about money, how we would scale the data so that we compare apples with apples, right? And it also plays a very important role down the stream for data science projects. So what you would do about missing data? You can remove data, or you can replace missing data with something that would make sense in the context, right? If you have lots of outliers or a lot of missing data, probably there is a more significant problem, and you can use a data lineage or data provenance to trace back where you have lost data. But then probably the data arrived from your partner, and the data was just somehow the sensor readings that you were processing just not there, or maybe they just lost the whole file when they performed that aggregation, and some historical data would be probably lost. So at least you would use a scientific way to go back, kind of a more organized way to process data. And then if it makes sense to plug in something which would make sense in the context, so be it. It can be interpolation. Sometimes using a mean value for that column is very important, right? And it depends, okay? Python comes with pandas. Pandas runs on top of NumPy library, and essentially it has a very nice interface for dealing with missing value. Here's an example of how you would treat missing data in column, second column. You just replace it with the mean value, and you specify that you would like to do updates in place. You are updating the existing data, which is probably not a good practice. Always keep the data unchanged. It's very much in line with functional programming. Don't mutate data in place. Always create a derivative product just by applying transformation. And in this way, you can maintain data lineage. So if you, for example, you miss certain things during the debug step, you can always go back and find out. Of course, if you're constrained in memory, your data just has several gigabytes, and you already observe data swapping to the hard drive, probably you have to do updates in place. But if memory allows you to maintain several iterations of your processing, don't do in place. Okay, so this kind of not a good practice, but sometimes it's the only steps that you have to do. Kind of when you're forced to do this. Okay, so there is significantly more that we can, I guess, be saying in this regard. And hopefully you got my idea that it's not only about Python. Python is great. Python is there. You can extend Python to run on cluster using PySpark, using the Spark system. It's very fast, blazingly fast. Processing is done in memory. It uses functional programming idioms. It has very nice Spark SQL integration with different file formats. But also pay attention to all other aspects that are around you. There are several kind of rings around your location. So you have to become aware of the context, what is expected from you, so that you really support people, as opposed to, I don't know, saying we just lost the data and give a big smile, like a sheepish one. Okay, so any questions?